Today's video will be all about solution stoichiometry. What is solution stoichiometry? Stoichiometry is solving problems using a balanced chemical equation. And in a balanced chemical equation, there are substances that is in the form of aqueous solution. That amount of substance could be related to the other substances found on the reactant or the product in the chemical equation. Under solution stoichiometry, we're going to relate volume, mass, and the mole of solutions in the reactants and the product of a balanced equation. We are going to relate volume and the mole using the molarity, which is a formula of mole of solute over volume of solution in liters, and the mole of a particular solution to other solution using the mole ratio in a balanced equation, and the mass and the mole using the molar mass. The first conversion that we could have under solution stoichiometry is the volume to volume conversion, and this could be expanded through this equation. In converting volume of a particular substance to other substance, we have to convert the volume of the given substance to the mole of that substance using the molarity. And then after that, the mole of the given substance will be converted to the mole of the other substance using their mole ratio or the conversion factor, which could be obtained from the chemical equation. And then that mole will be converted to the volume of the unknown substance using the molarity of that substance. For example, how many liters of 0.553 molar ammonium nitrate will react with 0.0648 liters of 0.734 molar ferric sulfate? Given the equation, 6NH4 NO3 react with Fe2SO43 to form 2FeNO33 plus 3NH42SO4. From that problem, we have given the molarity of ammonium nitrate, which is equal to 0.553 molar, the volume of ferric sulfate, which is equal to 0.0648 liters, and the molarity of ferric sulfate, which is equal to 0.734 molar. The unknown value or the required value will be volume of ammonium nitrate in liters. Knowing the given and the unknown values, we will have the volume to volume conversion, wherein the volume of ferric sulfate will be converted to the mole using its molarity, and that mole will be converted to the mole of ammonium nitrate using the mole ratio, and that mole will be converted to the volume of ammonium nitrate using its molarity. For the solution, we will have to substitute the given values to the equation. We have 0.0648 liters multiplied to its molarity, which is 0.734 mole over liter, times the mole ratio 6/1, and divide by the molarity of the unknown substance. We will have 0.553 mole. The final answer will be 0.516 liters. The next conversion that we have is the volume to mass conversion. In volume to mass conversion, it will be expanded to this equation, wherein the volume of the given substance will be converted to the mole using the molarity, and the mole of that given substance will be converted to the mole of the other substance using the mole ratio from the given equation, and the mole of that unknown substance will be converted to the mass using the molar mass. For example, calculate the mass of lithium sulfide that will react with 200 ml of 0.564 molar nitric acid if the products are hydrogen sulfide gas and lithium nitrate. Given the equation, A2S plus 2HNO3 to form 2LiNO3 plus H2S. Based on that problem, we have the given values of volume of the nitric acid, which is equal to 200 ml, which could be converted to liters, which is equal to 0.200 liters, and the molarity, which is 0.564 molar. The required value will be mass of lithium sulfide. And since we're going to have the volume to mass conversion, we will be using the molar mass of lithium sulfide. The equation that we're going to use will be volume of nitric acid will be converted to its mole using the molarity, and that mole will be converted to the mole of lithium sulfide using the mole ratio from the given problem or equation, and that mole will be converted to its mass using the molar mass, which is equal to 45.94 gram per mole. For the solution, we will have 0.200 liter nitric acid multiplied to the molarity, which is equal to 0.564 mole over 1 liter, times the mole ratio of nitric acid and lithium sulfide, which is 1 over 2, times the molar mass of lithium sulfide, which is 45.94 gram per mole. And then calculate. Cancel the same units. You will have the final answer is equal to 2.59 grams of lithium sulfide. And the last we could have is the mass to volume conversion. And this conversion could be expanded through this equation, wherein the mass of the given substance will be converted to the mole using its molar mass, and that mole will be converted to the mole of the unknown substance using the mole ratio from the given equation or the balance equation, and that mole will be converted to the volume using the given molarity. Example from the last balance equation, we have Li2S plus 2HNO3 to form 2LiNO3 plus H2S. We have to calculate the volume of 0.564 molar nitric acid needed to react with 3.75 grams of lithium sulfide. Based on the problem, we have given the mass of lithium sulfide, which is equal to 3.75 grams, and we have calculated its molar mass earlier, which is 45.94 gram per mole, and the molarity of nitric acid, which is equal to 0.564 molar. The unknown or the required value will be volume of nitric acid. So basically, we're going to have the mass to volume conversion. With that, the equation to be used will be mass of lithium sulfide will be converted to its mole using the molar mass, and that mole of lithium sulfide will be converted to nitric acid using the mole ratio. The mole of nitric acid will be converted to the volume of nitric acid using its molarity. For the solution, we have 3.75 grams of lithium sulfide multiply to the reciprocal of its molar mass, which is 45.94 gram, and then multiply to the molar ratio between nitric acid and lithium sulfide from the balance equation, which is 2 over 1, and then divide to the molarity of nitric acid, which is 0.564 molar. The final answer will be 0.289 liters or 0.29 liter nitric acid. Now, I want you to try this practice problem. You may pause on this part. The correct answer is 38.07 grams of lead 4 carbonate. In summary, we have the figure that shows the relationship of volume, the mass, and the mole. And that would be all. Thank you for watching. See you on my next one.